Today we're going to do recrystallization and melting point. So when we get a solid as a product, we are going to have to recrystallize it. And when it says to recrystallize it, it will normally tell us what the solvent is. So what we're going to do is we're going to take benzoic acid, all right, and so this is not pure, this is impure benzoic acid. And the solvent that we're going to use today is water. And so I weighed out 2.1072 grams of benzoic acid. I'm going to put it into the Erlenmeyer flask, and then I'm going to put in the water, and then I'm going to heat it on a hot plate until all of the solid dissolves. If all of the solid does not dissolve, I will need to add some more deionized water. Alright, now once it has crystallized, we are going to collect our crystals by vacuum filtration. So this is a Buchner funnel. It's got the holes in there, and it's got a sidearm flask. So this is going to be connected to the aspirator over here. Alright, and so when the water goes down, and you have to have a hose on here or the water would splash all over the place. So when I turn the water on, it is going to pull air in this hole. There's a hole in there, and it's going to pull air into that hole. Alright, so I'm going to hook up my vacuum filtration or suction filtration, so it is going to be then pulling air from the flask. And so the only place the air can come from is the top. And so I will get the correct size filter paper that fits on the Buchner funnel. And so then I will make sure all of the holes are covered, and then I will pour my crystals on there, and it will pull the air through the top, drying the crystals, pulling any liquid down into the sidearm flask. And that is how we're going to do the suction filtration. Alright. We will then, once we have our dry crystals, we will run a melting point. And so our melting point apparatus is over here. It's a Digimelt. Alright, and so I have it set up. It'll start at 112 degrees. The correct melting point for benzoic acid is 122.3. We will put our capillary tubes, so we'll put some crystals in our capillary tube, and then we will put that into one of the holes down here, and then it will start, and we will look into here at the crystal. Might be able to see that when we get to that point, and see when it melts. At what temperature will it melt? And that will give us the purity of our benzoic acid. Alright, so let's get started with the experiment. Alright, so the first thing I'm going to do is I'm going to add my 2 grams of benzoic acid to the Erlenmeyer flask. Alright, so I have my weigh boat, and then I will pour my benzoic acid into the Erlenmeyer flask. So this is impure benzoic acid. Alright, and it would be nice if I had a funnel for this. So percent recovery will not be very good probably, because I'm already losing some of this solid. 2 grams is a lot of solid. When you get your product, you will never get 2 grams of your product. You will get a much smaller amount, which will be easier to get into your flask. Alright, so then I'm going to add water. Now benzoic acid is very polar. Water is also polar. All acids are going to be polar. They have the OH. And so like dissolves like, and so it will dissolve in water, except not at room temperature. So some of it is dissolving, but of course not all of it. Alright, and so to increase the solubility, we're going to heat up our solution. Correct. Alright, and so I have the hot plate going, got my favorite spatula to get the solid out. So what's going to happen is I am trying to dissolve all of the solid. So when it says to recrystallize it, it'll give you the solvent. In this case, the solvent is water. If you are in advanced labs, they will not give you the solvent. You will have to do research and figure out what solvent is the best for recrystallizing your product. All right, but in the first classes of organic chemistry, the solvent is going to be given to you. All right, so this is going to then come to a boil and dissolve all of the solid. And then we will cool it and it will crystallize out. I have an ice bath ready just in case we want to crystallize it with an ice bath. That's always the colder it is, the less soluble it's going to be, and so you're going to get most of your solid out when the solvent is very cold. So we're going to heat it up, and that's why you're going to be using a Pyrex Erlenmeyer flask, so it can go from boiling to ice water without breaking. So more and more is dissolving as it's warming up. And to crystallize it again, there are many ways to do it. One is an ice bath. Another is to add a seed crystal. So if you get this into a liquid and you put it on the bench and it does not precipitate into nice pure crystals, you can add a crystal and it will grow from there. And if you Google super saturated solutions, you can see this occur. It's pretty dramatic. You add a drop or you just touch it with your spatula and the solid forms. Alright, so we are going to try to make a super saturated solution. So it's saturated because there's solid in the liquid. So anytime you have solid in a liquid, you have a saturated solution. Alright, to make it super saturated, you heat it up and then you increase the solubility and you get it to dissolve at a higher temperature. If you cool it very slowly and don't touch it, you can get it to be at room temperature and not precipitate out. And that is then a super saturated solution, because then if you just touch it, you shake it, you will get the solid precipitating out. Now if you were doing this and you had a really dirty product and you had things that will not dissolve in water, you would want to decant the solution to make sure that the impurities that are not soluble in your solvent do not come through or do not get stuck on your filter paper. You do not want those in there. So you would make sure that you get rid of anything that is insoluble. You may have to add a little bit more water. I added a little bit more of the benzoic acid. I have 2.1 grams instead of 2. All right, but I have my deionized water. Now, anytime you're going to add water, because it's not completely dissolved, you want to add a minimum amount of your solvent, in this case water. Because if you have it too much solvent, then it's hard to get it to precipitate back out. And again, this is cold water going in on a hot glass. You will definitely want to do a Pyrex, which is all that we should have in the lab. We shouldn't have any other kind of glassware that we're heating or cooling with. It should all be a Pyrex container. So I have a discolored solid in here that is not dissolving, and so I may need to fish that out, because that, if it doesn't dissolve in our water, it is not benzoic acid, it is something else. So once this starts boiling, if that still stays, probably can't see it, but we're clearing up the solution at the bottom, and we have some solid stuck on the sides, so I'm squirting down the sides to get that solid into the water down there. I see a black impurity. There's a black, almost looks like a boiling chip. So you put some boiling chips into a solution to make sure it doesn't boil. And sometimes you end up collecting that boiling chip as a product. That, of course, is not a product. All right, so now we're boiling. So I'm turning it down. And there is still one very impure compound. There's a block of something in there that's not dissolving, and so that would be something that is, well, is not what you want. It is not the benzoic acid. All right, but we can add some more solid, or some more solid. We can add some more water, make sure that it has enough of my hot solvent to dissolve everything. That is benzoic acid. So if it is not going to dissolve in boiling water, it is not benzoic acid. We do not want that. That is an impurity. Alright, and it is a pretty good sized piece, so we can break it up just in case it's not dissolving because of other reasons, like it's got a coating on the outside and it can't get to the water, even the boiling water. So it's looking like it all dissolved now. All right, so I do not see any solid in here. I do see that one piece of black impurity that's in there. It's still, again, it looks like a boiling chip. All right, but that big clunk of solid did dissolve. So now that it's all dissolved, now you take it and put it on the table and you let it cool. And as it cools, you're going to see the solid form. All right. Bring it closer, let's see. All right, so it is, of course, we've increased the solubility because the water is at 100 degrees Celsius. It is boiling water. That's actually higher than 100 because it is boiling with the benzoic acid in the solution. You have a boiling point elevation. All right, but as we are cooling this back down to room temperature, the benzoic acid is not soluble in water at lower temperatures, and so that benzoic acid will start to precipitate out of this solution. And there is a black, to me it looks like it's a boiling chip in there that we will need to fish out of there once we get it into our Buchner funnel. All right, I see some crystals growing. I don't know if you can see it. All right, so they are growing from the bottom where the coolest part is on this table, and then the crystals are growing on the bottom and they are coming towards the top. Hopefully you can see that on this video. I'm getting it as close as I can. And so the bottom is, you can see the looks like hair growing on the bottom. It is your benzoic acid crystals forming. And then you don't really want it to form crystals fast. The slower that you can form these crystals, the higher the purity is going to be. When you're doing research and you're making a new compound, you will always get a crystal of that if possible, and get an X-ray crystal structure to confirm your structure and give bond angles and bond lengths and things like that. Alright, so it's still growing on the bottom. What angle is best to see that at? But the bottom is pretty much covered with the benzoic acid crystals. Heater. So this one, the crystals did form at the bottom. It did not cool to room temperature as a supersaturated solution. So it's not going to be the dramatic, all the crystals form at the same time. This is going to be a slower, eventually your entire solution is going to be a white crystallized solution. And so it's going to basically be a solid in there that we're going to have to dig out, because we used as small amount of solvent as possible to dissolve everything. And so now it is crystallizing out very nicely. See the other side. Hopefully you can see the crystals on the side. You can see the crystals growing on the side, and now it's getting up to the top where they're growing. Now even some solutions are on the top starting to grow down, and they will meet in the middle and they will be solid everywhere. I'm trying to move it around so you can see it a little better. Hopefully you can see the solid in there. So that is a good amount of solid. So again, we want to make sure we get it all precipitated out as much as possible. We wanted it to precipitate out slowly, and so we did not stick it in ice water immediately. All right, it's still very, very warm, so we'll let it go for a little longer. But before we'll put it into our Buchner funnel, we're going to make it nice and cold with our ice bath. We're also going to wash it with some ice water as well. So any impurities that are in the water, we will wash that away when it's in the Buchner funnel. We want to use a small amount of water as possible because it's soluble in water. We just want it to get the surface of the benzoic acid free from any kind of impurity that was in the water. So if there was, sodium chloride in there, that would be washed away with the water at room temperature, at cold temperatures. And you notice with the benzoic acid, it is not very soluble with cold water. When we put it in there, it didn't seem like it was going to dissolve at all. It started to dissolve nicely as we heated up the solution. All right, so it is pretty much a big solid chunk in there right now. Okay, probably, well, let's see if you can see the solid chunk in there. All right, so it is a little bit of liquid and a lot of solid. All right, so I'm going to put the camera back down, and then we're going to do the suction filtration. So first we're going to cool it. All right, so I'm going to stick this in an ice water bath. I'm also going to stick my deionized water. I want that to be cold too, but I'm going to put this in here first. All right, so sometimes it's very difficult to get the crystals to form. This one, the crystals form very nicely, but you would, if it were not crystallized, you would stick it in an ice water bath, and then I like to spin it, all right, to cool it off quicker, and just the agitation of the solution sometimes makes the solid form. That's not the issue here. We already have our solid, so I would not have to spin it, although spinning it gives you more surface touching the cold outside of the flask, so it's going to cool it faster if you spin it. All right, so again, we have lots of solid in here to collect, and we still have our boiling chip in there that we're going to have to fish out. I'm going to cool off my deionized water a little bit, because I'm going to squirt some of this on the surface, and I don't want the water to dissolve our product. Anytime you're doing a recrystallization, we're starting with 2 grams, we are not going to get 2 grams back. You're always going to lose some of your yield when you go and purify your solid by doing a recrystallization. But purity is very important, so you want to have a pure benzoic acid. You don't want anything else besides the benzoic acid. All right, so what I want to do when I start my vacuum filtration is I'm going to turn it on, and then I'm going to make sure that all the holes are covered by pouring some of the solvent on all the holes. All right, and now I can see that it has formed a suction. So now the filter paper is flat on all of those holes, and it is going to pull through. All of the liquid is going to get pulled right through. All right, and so I'm going to try to get as much out of here as possible. So I'm pouring it in, and it is going to pull it right through. All right, so there's a lot of solid left in here, so that's why I wanted to have some cold solvent here. I don't want to dissolve it. I just want it to come out into the all right, and then as well, I said I would fish out all right, there. Black piece. All right, so we're losing some solid just by just getting the boiling chip out. I should show you how this is. All right, so again, I'm going to wash it with a little more water, and at the same time squirt out the flask. And then you can see that the liquid is being pulled through very quickly, so that the solvent doesn't stay up here on the top and dissolve my crystals. It's going right through. All right, and so you will then run the air, just let the air get pulled through the top, so it is drying your crystals. You want to make sure that your crystals are dry, pure dry crystals before you take the melting point. All right, so then we can collect them. So we weigh the So I would tear the weigh boat. All right, and I got the solid in here. Let's see, I should show what we're doing in here. So let's see if I can do this. All right, so in here is our solid. It's drying nicely. All right, so now I'm going to put that in the weigh boat, and then I'm going to weigh it. And then we're going to take a melting point. So we will have information on what percent recovery we had and how much of our 2 grams did we get back, and the purity of it by how close we are to the actual melting point. All right, so pull this off, collect it. And then if your mass is greater than your 2 grams, then you know for sure that your product is not dry. So if you ever get a percent yield or a percent recovery that is over 100%, which is impossible, that means that your product is wet. And now when it says, anytime it says to dry something, in organic chemistry they'll say to dry your liquid. That does not mean to sit there and wait for it to evaporate. When you are drying your liquid, that means you are removing water. All right, so wet is water. So when you're drying something, you are removing water. All right, so let's see what we got for a mass. Again, if it is over 2 grams, then you know for sure it is wet. It is not. 1.8911. 1.8911 grams. So we started with 2.1 grams and we got rounds to 9 grams back. So that's a pretty good percent recovery. All right, so we didn't do too bad losing much of our product. So now we have to take the melting point. So in order to take the melting point, we have our capillary tube, and so we have to, the capillary tube is open at both ends. All right, so I'm going to close one end by melting it. So I like my Bunsen burner. I am going to close one end of my capillary tube by heating it and melting it until there is no opening. Okay, it doesn't take very much heat for a capillary tube to get closed. All right, so, and it's hard to see since they're so small. All right, so we have heated the capillary tube, and now the one end is closed. The other end is still open. So the other end, I'm going to put some of these crystals that we have just made into this end. And so I'm going to collect some of my crystals into my capillary tube. All right, so I have some crystals in the capillary tube. All right, and so then I can tap it down. All right, and so now I have some crystals on the bottom. So you have to tap it down. There is a tube tapper on this instrument. All right, and so I'm going to put it into the instrument. Okay. This again, make sure that it's all sealed up. Tap some more down. Let's see if I can see it this time. All right, yeah, so I can see it now. All right, so we have our crystals. I'm going to try to show you. I don't know if this is going to work. All right, but in there, okay, hard to, all right. Yep, the one in the middle, there's three. The one in the middle is what we're looking at. I will try to move it. That's the one we're looking at. And you can see crystals. You probably can't from that view, but from my view, I can see the crystals. And then we will start. And it's going to preheat, and I set the preheat to 112. If we have a pure compound, it is going to melt at 122.3, and so I am going to set it to 112 to start. Once it hits the 112, it's going to say that it is ready, and then when I press to start it, it's going to increase temperature very, very slowly so that you can see the actual melting point. That you're probably not going to be able to see because I'm not sure what you can see through this lens with the light on, but you can see that the temperature is going up very quickly, and it's going to stop when it hits about 112. And then it's going to heat slowly, so it's slowing down now because it's getting up to the 112 area. And then it has a ramp rate of 2 degrees per minute, and then you look through the lens until you get the crystal to melt. All right, so now it says ready, and so then you just push start, and then it lights up the melt, and so it is now going to go up slowly until I think I push the stop point at 130 degrees Celsius. So it's going to go from 112, or right here to 111.4, to 130 before it's going to stop and then cool off. If it does not melt between 112 and 130, we do not purify our benzoic acid. All right, so it is still a solid in there. I realize you probably can't see, and it's hard for me to watch and watch. I can't hardly see it through the thing I'm looking through there. All right, so So this is how you take a melting point with a Digimelt. And now you just look at your crystals until they melt. I'm not sure what you can see, but I have it at an angle where I can see the crystals. Usually I would have my eye up a lot closer to the lens there. All right, we're at 115. All right, we're at 116. Temperature going over there, so you can, if it wasn't on a camera, you could see there, and then you just look to the right every so often to see what the temperature is and see how your crystals are doing. All right, so we're at 16.5 and they're still not melting, which is great. We don't want it to melt till at least in the 120s. 122.3 is the pure benzoic acid melting point. We're at 117, still looks great. All right, still looking good at 118. Melting points are not that exciting. You gotta watch it and the temperature the whole time. So, all right, we're at 119, still looks great. All right, we're at 120 and it still hasn't melted, which is great. We still got another 2 degrees to go before we want it to melt. $121. All right, now it's starting to melt at 121.6, and it is gone at 121.9. So that is a very pure sample of benzoic acid. And so when the directions say to do a recrystallization in, say, water, if it's benzoic acid, this is what you do. It doesn't give you the directions. It says recrystallize it in water. You take your benzoic acid, you dissolve it in water, and then you cool it, you collect it, you dry it, and then you get the melting point. All right, so when a solid is your product, you will do a recrystallization and a melting point. All right, so you will need to get your percent recovery and your purity check. Basically, your purity check is your melting point. And that is it for recrystallization.